All right, last one, 1.3e. This one should be pretty quick. I know that last one was pretty long. So what is freezing, melting, and boiling point? So by the end of this, you'll be able to define freezing, melting, boiling point, and then identify the freezing, melting, and boiling point of water. And then your vocabulary is, you guessed it, freezing point, melting point, and boiling point. All right, so what is freezing point? So we just talked about states of matter. We got liquids, solids, and gases. And we talked about how you add heat and it moves the state of matter, it changes the state of matter. Adding heat to a solid makes it a liquid. Adding heat to a liquid makes it a gas. And then, you could cool it back down. So freezing point. So this is the temperature where a liquid becomes a solid. So water freezes at 0 degrees Celsius, or what you're more familiar with is 32 degrees Fahrenheit, right? When we're hoping for that snow day, we want it to be 32 degrees outside or cooler in order for it to snow and for it to stick. All right, melting point. So melting point is the temperature where a solid becomes a liquid, so it's the reverse. So water melts above 0 degrees Celsius and above 32 degrees Fahrenheit, right? So melting, you could kind of have it like melting slash freezing point. Because their temperature ranges is the same. It's just, are you below that or are you above it? So last one is boiling point. So boiling point is a temperature where a liquid becomes a gas. And water boils at 100 degrees Celsius, or what we're more familiar with, 212 degrees Fahrenheit. So if you look at this graph here, we can see the states of matter and how they change when heat is added. So if we start out here at 32 degrees, right? Everything below 32 degrees is going to be ice, all right? And then everything above 32 degrees, but below 212, so anything in between here is going to be a liquid, which in this instance is water. And then everything that is above 212 turns into a gas, right? So as we're adding heat, our ice melts and turns into water. We're adding more heat and it boils and turns into a gas. And then if we did the opposite and cooled it down, so we'll cross this out. If we're adding, we're making it colder, right? We're removing heat. That gas will condense, right? We're lowering the temperature. It's going to condense enough where it's going to turn into water. And then if we continue to cool it, it will turn into ice. So, right, we can go either add heat and go from an ice, water, gas, or we can add cold air to it, cold temperatures, and it can reverse it. So this is a continuous cycle.